Thank you very much. It's wonderful to be back in Brussels. I have been given the challenge of discussing with you the next 50 years of physics in a dark room without windows an hour after lunch. So I already see some of you recoiling in horror at the prospect of equations and tensor calculus. I'm not going to do that. I've called my presentation a theory of everything else. Physicists today, professional physicists, are developing various theories of everything to try to reconcile the two major successful theories of physics today, general relativity and quantum mechanics. There are a couple of dirty little secrets in there that they are not telling you. The first one is that these two theories, each of which works very well in its own domain, are in violent contradiction in most of our world every day, especially with gravity. Therefore, the idea is to try to develop theories of everything that would reconcile somehow, like string theory and others, would reconcile these two dominant views of physics. The other dirty little secret is that in all that, we have left out a missing child. The missing child is the little sister of physics, is the physics of information, and that's what I would like to talk about this afternoon. The physics they teach us in college and in universities is the physics of energy. It has to do with lasers and colors and particles and mass and fields, whatever a field is, and acceleration and inertia and all these things that you've been exposed to in high school or college and university. The problem is that they also teach us that information and energy are two sides of the same coin, but they never bothered to teach us the physics of information. They continue to teach us the physics of energy. Now, going back to the 19th century, James Maxwell, discussing thermodynamics, took a very simple idea that if you pour hot liquid into a cold liquid, there will be an average temperature of the liquid between these two components. The only way to stop that would be for a little demon, Maxwell's demon, to be there and to separate these molecules. But absent this demon, the law of thermodynamics will say the two liquids will mix and will reach an average tepid temperature. Leo Szilard, who was a colleague of Einstein in 1929, went one step further and said for the demon to be able to do this, the demon needs information about which molecules are hot and which molecules are cold. If the demon knows that, then the demon can, in fact, keep the two liquids separated and they will never reach an average temperature. But that means that there is just as much information as there is energy in the system, and that information and energy are, in fact, the two sides of the same coin. So where is the missing sister of physics? The physics of energy has to do, again, with particles and atoms and fundamental forces and mass and entropy and fields and space dimensions, x, y, and z, and t for time, and momentum and inertia and speed and so on. But we never talk about similar concepts on the side of the physics of information, and my argument is that in the next 50 years we will. I should disclose to you, I'm in a field where everybody works on full disclosure, so I might as well confess to you that I dropped out of physics. I passed, I have an advanced degree in physics only because I was good in math, so I could work out the equations and get the answer. But then I dropped out of it for a couple of reasons. First, I could never understand what they meant when they said time was a dimension. They say, okay, there is x, y, and z, so I get that from common experience. And they say, think of time the same way, only in the equation you put a little I in front of t for square root of -1, but don't don't think about that. And then you treat it the same way and everything works fine. And that's in general relativity and other areas of physics, that's what you do. I could never get that because in X, I can go this way or I can go that way. In time, I cannot. I'm not allowed to do that. So we're very good at talking about how time passes. We don't know why time passes. Similarly, we're very good at talking about how things fall down. We don't know why they fall down. And again, this is not something that you've been taught in physics in college. They never said that they couldn't explain those two things. The third thing that disgusted me was particles. We have particles inside the atom, and then we have particles inside the particles. We have particles inside electrons and photons and everything else. And then, since it still doesn't work very well, we have particles of subparticles. And that reminds me of something that happened to astronomy in the Middle Ages when they had cycles and epicycles of epicycles. If you keep doing that, everything works fine, except that that's not the way reality works. So I thought they should go on doing this. They should go on with the physics of energy. We achieve wonderful things with that science, but that's not what I really want to do. So I went back to the missing sister, looking for the missing little sister of physics. And it turns out it's asking fundamental questions about the nature of time and also about some of the things that happen in our lives, like coincidences. On July 20, 1996, we had a house in the country north of San Francisco, a wonderful area full of redwoods. And we had some friends over for an evening for dinner. And one of our friends was a woman who said she was going to be in a play in Mendocino County, and in the play she was going to read something in French, and she had not practiced French for a while. So she asked us if we had a book in French, and we had a bookshelf with English and French books. My wife pulled out a novel, which was this novel by René Barjavel, La Peau de César, and she gave it to me, and I opened it at a random page. And I read a passage at random, which was, I was in the Boeing that blew up after takeoff at Kennedy Airport, a bomb in the hold, 132 dead. Remember? Well, this was 3 days after Boeing took off from Kennedy Airport and blew up over the Atlantic. And we were shocked by this. And if you talk about this kind of coincidence with your friends, you'll find that many people have, in fact, had that kind of experience. This was not precognition. This was 3 days after the TWA 800 accident. But it shook us up, and then we forgot it. This is the kind of thing that you sort of brush out of your awareness. Some scientists have thought deeply about this, going back to the Middle Ages. Fascius Cardan, in the 15th century, writes in his diary that he had performed some rites to make the elementals of the air appear in his laboratory. This was a very fashionable thing to do in the 15th century, and these creatures appeared before him. There were 7 sylphs, the creatures of the air. 2 of them were the chiefs, and they came forward, and he asked them what they knew about the nature of the universe. It turned out the 2 sylphs disagreed. One of them said, well, God created the universe once and for all, and here we are. The other one said, no, God created the universe from moment to moment, and if he should stop for a minute, everything would disappear. So this clicker is not the clicker that I was given earlier. It's another occasion, another instance of the same clicker. But these clickers are being generated by something in a higher plane, which as a software engineer, I understand perfectly. This makes sense. It makes no sense in terms of the physics of energy. It makes perfect sense in the physics of information. And here you have the 2 models of the world. You have the classic physical model, and you have quantum mechanics. A number of people have more recently been looking for the little sister of physics. starting with Wolfgang Pauli, one of the founders of quantum mechanics, Carl Jung, and there is extensive correspondence between Pauli and Jung, Paul Kammerer, Arthur Koestler, David Bohm, Max Wermans, Philippe Guillemot in France, Landauer and Seth Lloyd, and many others. Carl Jung argued with Pauli, and Carl Jung compiled a catalog of coincidences that had happened to him. In one case, he was at a conference in another city, and in the middle of the night, he woke up with the feeling there was somebody in the room. And he actually got up and checked, and there was nobody in the vicinity. But he had the feeling of something hitting his forehead and something hitting the back of his head. He went back to sleep, and the next day got a telegram that one of his patients had committed suicide by shooting himself in the forehead, and the bullet had lodged itself in the back of the head. Carl Jung, in his books, mentions a number of these remarkable coincidences. I had another occasion like this. In the 70s, I was concerned about the number of cults growing up in California, but also in France and elsewhere, around the idea of extraterrestrials. And some of these groups call themselves the Melchizedek cult, or they used as inspiration the biblical figure of Melchizedek. This is a representation of Melchizedek at Chartres Cathedral, which is very beautiful. Melchizedek is a very interesting, very mystical, very mysterious figure in the Bible. He's a very powerful figure because he initiated Abraham and actually was the origin of all three religions of the book, the Islamist, the Jewish, and the Christian religion. I was going to an interview in Los Angeles, took a taxi at random from the flow of traffic, got to my interview. When I got home, I looked at the receipt from the driver, and the receipt was signed Melchizedek. Now that got me on a strange series of thoughts. At the time, there was research going on at Stanford Research Institute on parapsychology. I was part of that program, the program of remote viewing. Uri Geller was there. Uri Geller thought that he could communicate with extraterrestrials on board a platform called Huva, and that he was getting communications from them, which enabled him to do what he was performing in our laboratory. I thought, well, this seems to be the same kind of communication. Something is communicating with me. And over the next several weeks, I did a number of experiments, and I convinced myself that these coincidences, some of them mean something powerful, as Jung said. Others mean absolutely nothing. It's just the way the world is organized. So let's go back and do a little bit of software thinking. If you have a small library, this is the Library of Congress, 33 million books. 33 million books is nothing. I mean, that's what Facebook does in one afternoon. Today, Google is getting 35 hours of video per minute uploaded to the YouTube site. So if you have a small library, you can still work with coordinates. You have shelves, and you have vertical stacks, and so you have X, Y, and Z, and that works fine. If somebody sends you 10,000 books, you can push the existing books a little to insert the new books. If you have enough staff people at your disposal, it works fine. If you have a modern library which looks like this is Google, this is Facebook, this is Twitter. You can't do that anymore. You can't use dimensions. You sprinkle the information that comes in statistically in virtual memory, in an infinite virtual memory. And then you have a hashing code that enables you to get it back when somebody asks a question of Google. And the result is statistical. Some of it means something, some of it means nothing. This is now starting to be mainstream physics. Dr. Guillemot in France is a CNRS physicist, and in his latest book, La Route du Temps, The Road of Time, He argued that synchronicities are caused by a double causality. Our intentions cause effects in the future that become the future causes of present effects. Again, this is now becoming mainstream physics. To conclude, there are 4 requirements for the new physics of 2061. First, we should recognize the universe as a subsystem of a meta-reality of information structures. It's all information structure, and it's all simultaneous. I don't mean it's a database. I mean, I don't mean to use analogs with current crude technology. It's something obviously much bigger, much more complex, but you get the idea. We should recognize dimensions as a cultural artifact. We create dimensions because we have small libraries and we need X, Y, and Z. But we don't need them in physics. So we should do away with the concept of dimensions in the physics of the future. The present is overdetermined. As Guillemot says, it's determined from the past and it's determined from the future. And finally, consciousness is generating the impression of space and time. That's what space-time is. It's consciousness traversing associations in this world of information and creating the illusion of space and time. So my proposal to you is that we let physicists continue with the physics of energy. They do that very well. They will eventually have a way of reconciling relativity with quantum mechanics. Let's go on and look for the missing sister. Thank you very much. Thank you very much. It's wonderful to be back in Brussels. I have been given the challenge of discussing with you the next 50 years of physics in a dark room without windows an hour after lunch. So I already see some of you recoiling in horror at the prospect of equations and tensor calculus. I'm not going to do that. I've called my presentation a theory, took a very simple idea that if you pour hot liquid into a cold liquid, there will be an average temperature of the liquid between these two components. The only way to stop that would be for a little demon, Maxwell's demon, to be there and to separate these molecules. But absent this demon, the law of thermodynamics will say the two liquids will mix and will reach an average tepid temperature. Leo Szilard, who was a colleague of Einstein in 1929, went one step further and said for the demon, therefore the idea is to try to develop theories of everything that would reconcile somehow, like string theory and others, would reconcile these two dominant views of physics. The other dirty little secret is that in all that, we have left out a missing child. The missing child is the little sister of physics, is the physics of information, and that's what I would like to talk about this afternoon. The physics they teach us in college and in universities is the physics of energy. It has to do with lasers and colors and particles and mass and fields, whatever a field is, and acceleration and inertia and all these things that you've been exposed to in high school or college and university. The problem is that they also teach us that information and energy are two sides of the same coin, but they never bothered to teach us the physics of information. They continue to teach us the physics of energy. Now, going back to the 19th century, James Maxwell, discussing thermodynamics of everything else. Physicists today, professional physicists, are developing various theories of everything to try to reconcile the two major successful theories of physics today, general relativity and quantum mechanics. there are a couple of dirty little secrets in there that they are not telling you. The first one is that these two theories, each of which works very well in its own domain, are in violent contradiction in most of our world every day, especially with gravity.